Okay, so today we're going to have a chat about the Data Center Association commissioning special interest group. And I guess a good place to start would be just a broad outline of what it was set up to do and the kind of activities you get up to. Maybe Ian, if you can start.
Yeah, I mean, like all special interest groups, it's sort of a collection of like-minded individuals that are interested in the subject. But as far as data centers are concerned, it's a particularly useful group because, you know, classically data centers are a collision of many disciplines. It's not like electrical engineering or mechanical engineering or fire engineering or security. It's everything. And at different stages in each project, there's various levels of testing, witness testing in works, testing on site as individual systems, and then trying to bring them all together. And at the end of the day, the client deserves, I suppose you could argue, well, some clients don't, but you could argue that the client deserves proof that what he bought as a bunch of components actually works as a system. And so the special interest group is there to encompass all of the disciplines that want to be involved. I mean, for example, the classic one is the classic two, really, power and cooling. You want to have your power system tested at full load. Is that important? Well, I guess from a technical point of view, it's important. Will it ever run at full load? Absolutely not. So is it more important to make sure you test it at partial loads as well and record the performance so that you end up actually imitating what the load's going to be like when you're in service and not having surprises like, you know, choosing a UPS that's very efficient at full load but not so efficient at partial load, and then it goes, you know, you tick the box, you test it at a full load, test it at 10% overload, everything's hunky-dory, and the customer turns it on and says, hang on a minute, it doesn't work very well now. I've only got 20% load. Everything's not quite working correctly. So it's a question of, I think the special interest group is purpose is to really look at the, if you like, the codes of practice or the normal practice and challenge it. You know, challenge it. The other example, I said power and cooling. Well, power is an interesting one because, for example, these days most UPSs for data centers are sold as for a unity power factor 1. I know why it started. It started about 20 odd years ago because no one could explain to customers or IT departments what the power factor meant. So, you know, you go back far enough, we used to make UPSs that were 100 kVA and a power factor 0.8, which was traditional, which meant they could either do 100 kVA, 1000 VA, or 80 kilowatts. And for people that don't understand power factor, that's always a mystery. Well, why can it do 1000 kVA but only 80 kilowatts when kVA is volts times amps divided by 1000, you're done. The point is that the UPSs were built that way. Then along came a really clever UPS manufacturer who shall be nameless but is no longer in existence and got taken over once and then twice. And they realized that explaining power factor to customers was really very complicated. And they realized also that their UPS could be rated at unity power factor. So they could say, here's our 200 kVA box. By the way, it's also 200 kilowatts. They really did grab a slice of the market, and from that moment on, everyone sort of followed the theme. Now you've even got the extent where some people say should never look at the kVA rating of a UPS. Only the kilowatts counts. Interesting comment. So we test it with kilowatts. The load is never unity power factor. So if you've got a 500 kilowatt UPS, you test it on site with a load bank, resistive load bank. You say it does it, tick the box. It does it for an hour, tick the box. It does it with 10% overload for an hour, tick the box. Actually, it's never ever going to be loaded up to that because the load is usually somewhere between 0.9 and 0.95 capacitive. So it should be tested that way. And there's things like that, anomalies in the system, which I think the special interest group should probably address, even if it makes no change. It should probably address and make sure that customers know that testing something just with resistive load bank doesn't prove very much. Yeah, better to have some inductance or some capacitance or something closer to the real load. The opposite, or not opposite, but the corollary of that is in the cooling system. You can't choose the time of year when you do your witness test on site. You can, I guess, you could choose the time of year when you take test figures from a climate chamber, for example, a test in a factory in a climate chamber to show that the equipment does the work at, you know, when it's 0 degrees outside or -10 or +20 or +40. You get that idea, but you don't know when you get it on site that it'll work like that, and you can't have it. You haven't got any control over the temperature outside or humidity. So here we are. We gaily test everything, and we tick the boxes. Usually resistive, and ignore what the outside conditions are, and we end up with a test certificate that doesn't really mean very much, because the equipment is going to vary in performance with the outside temperature. And whilst a long time ago that wasn't very important, because the systems weren't very efficient and they were usually oversized, so you could almost throw anything at them and they'd work okay. Nowadays they're a bit like sort of thoroughbred racing horses or Ferraris, you know, which need a service every 1,000 miles to get to tune the injection system back up again. They are thoroughbred systems, and they do vary a lot with outside temperature. So I think the special interest group, the cooling people in there, should think about things like the difference between what it says in a catalogue and what you're going to use it for in reality. And then you can take those two things, and I'll shut up and then ask me another question. You can take those two things and extend it across the whole breadth of the entire mechanical and electrical systems in the data center. You know, what about harmonics in the power system? What about the fire system? Are you ever going to test the gas suppression system? Probably not. Are you going to test the detection systems? Yes. Under what conditions are you going to test, etc.? So we need to look at all of the codes of practices, the standards in all the different countries that the DCA cover, and decide whether or not there's gaps, and whether we can add value to the testing regime, simply to make sure that when a customer says, I want my system tested, and he can define what he means by tested. I mean, even a black start, you know, no power on, start with nothing and build up, or just make sure that the systems individually do the performance, but make sure that he gets a meaningful result, not just an extension of witness test, which is a tick in the box exercise. So it's a interesting special interest group because it's got so many elements.
Okay, and Paul, in terms of I guess testing per se, do you think data center owner operators are all fully aware of their sort of obligations, responsibilities when it comes to testing? Do you think there's enough of that carried out by most of them? Are they perhaps too prone to rely on the information they're given by the vendors, you know, tell them what, you know, the UPS might be doing or cooling, and just trust that? And in terms of testing, does it start at the factory wherever the kit's been made, and then what a bit about the sort of on-site when the kit actually gets delivered to the data center?
There's from I think the 5 stages of commissioning. If you follow the various steps, you use a load bank across probably stage 3, stage 4, stage 5, factory acceptance, site acceptance, and the last one being the integrated testing. That's a commonality which brings together both the cooling and the mechanical systems, either in isolation or at the end of the IST, the integrated system test, that is done prior to handover. The last 10, 12 years of load banks being used across the data center it's given the owners and the industry the ability to learn from mistakes. We've still got issues of that you experience in commissioning. That's part of construction, and they are not as bad as they used to be, and people are more efficient. You know, a test of 1 to 2 weeks is now expected, but it can, we didn't foresee the COVID situation whereby restrictions and delays occur, so the testing goes to 3 or 4 weeks. So experience says yes, you have to use a load bank, and the reason for the commissioning group to come together was it came from a couple of the load bank companies who wanted to make sure that the equipment being used was sensible equipment, useful equipment, to allow the, I was going to say the word certification of the data center, or the validity of the testing to be of quality. And if you're using the right load banks to deliver the design criteria within the heat load test, then you can achieve that handover from design to operation. And when you go forward, Ian mentioned before about 20-30% load. If you've got that data in your commissioning, then you can refer back to it in the future where the load is realistic. You've got a checkpoint, you've got a reference point, datum point. One of the ways the industry has been led is to certify the buildings at full load. And if you've got a 1,000 kilowatt design, you have to prove it to be 1,000 kilowatt. So you run it at this full load value, and you see everything working very nicely. But if you can step it up towards that point and take your measurements and the data across the space for cooling and temperature and power, you've got this datum point to go back to, and explaining that to the wider audience, or to bring the experiences of the data center, the load bank companies in the data center, as one of the starting points of where we set off just over 12 months ago. As Ian came on board to referee the different load bank companies, shall we say, the wider perspective of what goes on outside the white space brings in the other stages of commissioning, the other systems that we're using and that are used in the data center. So it's widened its original objectives, and it is a very challenging exercise putting this together. There's going to be a lot of effort needed, and there's a lot of topics, and there's a lot of experience which has to be translated, a generational knowledge transfer of what we've all seen to hand on to the next generations of people going into this space.
And in terms of, I mean, it sounds like, I think both of you seem to have talked about testing, commissioning in what I say a greenfield. So, you know, a data center being built, it's empty, you're gradually populating it with plant, and you test as you go along, ultimately being ready for, you know, day one when you open. How does that sort of regime differ from when you're adding, you know, critical bits of plant into a live data center? Do you still have the luxury to be able to carry out testing in the same way? Maybe Ian, you can sort of highlight any differences or the similarities.
Insurance is one of the issues on that. Getting the insurance cover to work in a live space with data, a challenge which we probably need to mitigate or help mitigate as we go forward in the group. I had a discussion last week with somebody, and he mentioned it, and I said, don't forget your insurance, and he said, I'm having lots of conversations about how to allow it to happen.
Yeah, the other thing is, you touched on an interesting point, you see, because, you know, we call it the critical space. All the equipment costs a lot of money, and often the load really is important. Sometimes it's not. Sometimes it's tap dancing dogs or whatever. But the point is that we call it a critical space. Would you honestly think or expect someone to expand a system? Let's say add another megawatt onto something, power and cooling. Well, when the first phase was live and running, would you expect them to put it in, turn it on, and hand it over without it being properly tested? No, you wouldn't. So clearly you've got to find ways of doing it, and that's part of the art of testing and commissioning, is finding ways to segregate out the new part, test it to within an inch of its life to make sure it does what it says on the tin, and then hand it over as a fully functioning system. I mean, I do legal expert work, and I've done it for a few years now, but I'm always really surprised. Some of the disputes, they're beyond words. You look at it and you think, how did someone hand something over like that, and how did someone accept it like that? And then not why are they surprised when 2 years down the line something fails or some operator makes a mistake and the whole system collapses? You look at it and you say, well, it was never going to work, was it? It was never going to work. You put something in, you didn't test it. Oh, well, it was difficult to test because we couldn't turn that bit off to put this bit on. So we put it in and we put in the same, and then you think, ooh. And before you know where you are, you've actually opened up a book of saying, this is what you shouldn't do. And I think that's to Paul's point. That's the most important thing we can do, is we should be able to come up with a recipe book or a warning book, if you like, and saying, this is the perfect scenario, this is the dangerous scenario, and between the two things, these are all the things you need to look at. Because we've never, other than someone saying all systems should be tested at full load and put together and an integrated system test done, and then it'll be fine. That's proven quite a few times not to be true. I'll give you a little example.
I was going to do that, but go on.
You can have a go in a minute.
I'll see. Yeah.
A customer that had a certain kilowatt rating in the room, and he put in Unity Power Factor UPSs, so 1400 kilowatts of UPS, N+1, and he put in a cooling system which was also 1400 kilowatts. It was meant to be N+1, but I looked at the system and I did a tour of it and was shown the system. He said, what do you think? I said, well, I'm a bit surprised. You haven't got any redundancy on the cooling. He said, yes, we have. I said, no, you haven't. He said, yes, we have. I said, no, those units are 200 kilowatts. He said, no, they're not. They're 237. Oh, really? I said, well, I can have a look. And there, I looked at the nameplate on this big box, 237 kilowatts. It was even called a 200 kilowatt unit on its brand title. So I rang up the manufacturer and said, what are you playing at? I know this box. I've consulted for you in the past. That's a 200 kilowatt box. They said, oh yeah, but the end customer insisted that we made it for a certain delta T between the input and the output of the IT equipment. And they insisted on doing it for 15 degrees. So that's quite high. And I went to the customer and said, is it true that you said you wanted 15 degrees delta T? He said, well, yes, because the delta T is going up over time and we wanted to future-proof our system. And I said, yeah, well, the problem is, I said, the equipment that we bought is rated for 200 kilowatts at the typical 7 degrees delta T, but at 15, you can restamp it for 237. It'll do it. He said, oh, that's great then, isn't it? I said, no, because you've only got 4 degrees delta T at the moment. So therefore you haven't got any redundancy. In fact, you've got a room for about 1300 kilowatts at your present load. And the UPS won't do it anyway. So there's an interesting thing. So he went for what Paul said a moment ago. He was going for certification. And even the certification company didn't notice that. In fact, I think they kind of did notice it, but they said, well, what have you asked the contractor to provide? The customer told him. He said, oh, that's all right then. Instead of saying, well, that's all right, but it doesn't reflect reality. So there's a perfect example of a new system at the time, only 2 years ago, that was handed over as big system, 6 rooms at 1400 kilowatts each, big system handed over, not quite being able to be capable of doing what it said on the box. And so that, that because no one could say, well, where can we find out a test regime for a cooling system that's independent of the manufacturer? You can get lots of that are, ask a cooling manufacturer to give you a commissioning script for their equipment and they'll give it. But there isn't anyone that will say, here's a commissioning script for a data center and what you've got to look out for,
So Paul, have you were giving us another example?
As we've seen over the last 12 months of everybody going on video calls like this one, and the outages have been seen, and there's always a secrecy behind the internet and the NDAs that everybody signs up for. But when you've got the rollout of these redundant or these phased or the facilities, so you've phase one is 2.5 megawatts, phase two 2.5 megawatts. You don't test them together at 5 megawatts, and these have been sat in mothball waiting for things to happen. And 12 months ago, as we saw everybody going online and the uptake in digital services, the facilities were being rolled out, and that was the time when phase A and phase B were being put together in a live action, or in a live status, and things failed. They've not been tested because it wasn't needed, so it wasn't used. And you'll never find out exactly what went wrong, and but the ability to look at on a more holistic testing regime, as now we're seeing that more and more now. People are wanting to do more of the big end testing, and having the availability of the load banks, I think, goes hand in hand with the phase rollouts, where if you're just doing just a 2.5 megawatt room, I remember the days when it used to be a 200 kilowatt room, but as you are testing to that size, the contractor wants to get paid for the work. The next phase might be off another contractor. It might be him again, and he wants to roll the cash flow. You don't have that need to do the testing, and the load bank companies haven't had enough equipment to support that. And those, as I said, those two I think go hand in hand. Now they're looking to do the bigger scale testing. More equipment's needed, and the load bank industry has to respond to provide the equipment. Whether there is enough equipment in the industry to support the number of builds going on, I don't think there is. But we have, there's only so many commissioning teams that you've got as well. And if you're not able to get enough power to do two rooms of 2.5 meg, then you're not going to do that test. So there's hidden reasons which you don't always appreciate why things fail down the line. So if we bring these into this is the experience point I mentioned before. We want to be able to, not that we are important making load banks and the load bank companies, but they are needed. And if we can share out the experiences of where we've seen things go wrong or where we can show an improvement, then we can contribute. Possibly you could call it neutral to the cooling and the power systems, because we're not doing those systems. And it's a benefit to have this presence of our little industry within the biggest industry of data centers.
In terms of it sounds as if the owner stroke operator of the data center is the best placed person to carry out all this, but do you think there's any sort of pushback on the manufacturers? I say I'm sure they're not deliberately misleading when they come to sell UPS systems or cooling, but clearly there's something of a disjoint between what the data center customer thinks they're getting and what they actually get. How do you see that getting? Again, do you think your group will be able to come up with a series of definitions and expectations, or how do you resolve that?
It's in expectations of the commercials. If you're buying a piece of equipment, you want to get paid, and you are only contracted to supply and to deliver. Then anything happens after that is, you can't be the UPS company can't be responsible for the generator, and you can't be responsible for the cooling system. And it's this isolation of vendors, and that's always going to be the way. And it's the project team, and if they've got a good commissioning agent alongside the project team, then you will overcome a lot of these issues, and you'll have a stronger success of the final switch on and the commissioning.
Okay, so Ian, can I just ask, how big, I mean, we're talking about this, how big a problem is it? I mean, if you're talking about, say, 10 new data centers being built, are 50% of them going to disappoint their owners because they don't perform to expectations? Is it more or less than that? So, Ian?
Well, as Paul said, most people keep it quiet, and the news of failure only leaks out if enough customers complain they lost service. But to show how extreme it can be, you know, we've had this fire in Strasbourg where 3 data centers burnt down. Turns out they didn't have a fire suppression system. I mean, you know, you couldn't make it up. They did sell very cheap space. That's true. They were a low-cost provider of data center services, cloud. In fact, the chairman, I think, from if I can read between the lines, kind of blamed his customers for the fact that they're complaining about the fire losing their data, because he said, we must have known what you were buying. That's why it was so cheap, more or less. I'm paraphrasing, but there's a big difference. There's a perception of people have about data centers that they are centers of excellence, and some of them definitely are, but not all of them. Yeah, and some of them are legacy ones, and it goes beyond that. So it goes further beyond that. There's also I think a job for the data center specialist interest group and commissioning and testing to push testing of generators. But I mean, I'm talking about every month or every quarter or every year after they've been installed. Why? Ask most data center operators, not the bigger ones because they'll be aware, but let's say some of the smaller ones. Ask them if it's okay to run your generator below 30% load. And a lot of people say, well, of course it is. You can go from 0 to 100% load. It's only ever tested at 100% load, only or maybe 75 and 50, but test at 25% load. Actually, if you're nosy and you go on a witness test to a genset manufacturer and you ask, well, there's one I've got in mind, I won't say who it is, but well, I could. They do a good job, but ask them to test the generator on a witness test at 25% load, and they say, no, we can't do that because it infringes the warranty on the engine. And it's a fact that if you constantly run diesel generators below 25%, they don't burn the fuel properly. The fuel condenses in the exhaust system. And one day when you have a real mains failure and the temperature of the exhaust system goes past a certain level, it ignites and causes a fire, which destroys the engine. It's called wet stacking. There's a perfect example where the data center industry should have somebody like the special interest group we're talking about saying, you should have permanent load banks on site unless you know you're going to get more than 30% load on your gensets.
There's the emissions 5 regulations, which are now being put on generators. In order to overcome the constraints of compliance to these emissions, these new standards, the gensets are required to be run at 30%.
Yeah.
So you have to put a load with them in order to meet the. And I've got one genset manufacturer who we deal with on this, and he makes sure that the gensets have got a 30% load on them. So we're actually having.
I'm sorry, and I'm just following up. Am I right in thinking as well that, excuse the non-technical, but if fuel is left in a tank for long, it stagnates, and then when it's actually required, it might not be able to do the job required as well? Is that another sort of angle that people only maybe come across when it's a bit too late because they've done nothing about it?
Yeah, usually it's too late, but there's a whole industry in what's called fuel polishing, fuel management. You dewater it and filter out the bacteria, but it doesn't. And it's not just diesel engines, and it's not just data centers. It's everywhere. I got a couple of sports cars, and I put them away for the winter. And last winter, the lockdown winter, I got them out of the garage, and one of them wouldn't start because I'd put it away 4 months ago, and the fuel had gone off in the tank. Bacteria grow, begin the bio content of the fuel. But the point is, there isn't anywhere for someone to go and ask someone about this. I mean, you see, the point is that you ask a specialist, they're only going to tell you what they want to tell you. If you find a specialist in fuel filtration and management, who sell fuel polishing equipment or a service, of course they're going to tell you that you need to do it every 6 months. They wouldn't do anything else, would they? But there isn't any independent view that says actually what they're telling you is totally essential. You've either got to burn it or treat it, and once you've treated it, it's back to fresh diesel again. It won't cause you any failures. But there's been spectacular failures over the years of contaminated fuel being sent to site, refueling tanks with contaminated fuel, and then 6 months later the utility fails. All the gensets ran for about 20 seconds and all stopped because all the injectors were blocked up. There's lots of it. There's lots of stories like that around, and because there wasn't an industry independent place for getting that information about diesel generator testing, for example, you're not going to find it. The diesel genset manufacturers don't put them in. Their agents do. Their agents are responsible for installation, the exhaust system, the attenuation, and also then often the servicing afterwards. But then customers go and divide up the service contracts into third-party maintainers to save money. And the third-party maintainers say, well, we'll do exactly what we're paid for, which doesn't happen to include cleaning the fuel. So then we end up with an education system, an education problem, which I think the Data Center Specialist Interest Group can address. And the point is, there are so many disciplines that we can't do it on our own. We need all of those other disciplines to join and come up with their wrinkles on the, I mean, I know about the power thing. I know a bit about the cooling thing as well. Paul sees the whole holistic problem when doing integrated system tests. But can you imagine how many different levels of switchgear testing, emergency power off testing, fire alarm systems, suppression, detection, access control? When a fire alarm system goes off, what happens to the fuel in the generator room? Is it pumped out to the bulk tank? Has anyone thought about that? Is there a regulation for it? Are the regulations different in every country? Yes. So you've got this situation where, we've got lots of different countries in a region with different rules locally for many things. And nowhere can you pick up a book and it says, or a list of documents written by experts and free that says, when you're doing this, test this, and be careful of these points. A list, a watch list of be careful of these points, and just a brief explanation of why. Because then the person that's responsible for setting up the scripts for the testing is going to look down the list and go, well, I'll ask him about these. It doesn't matter whether he doesn't know about it. Now he's got the questions. He can say to the testing guy for the cooling system, when we do the capacity test, what airflow are you expecting? What temperature difference between the outlet and the inlet are you expecting? What will be the effect of the climate? Now, whether you can do anything about it doesn't actually matter. The point is, you've asked the question, you get an answer, and then you can make a decision based on how meaningful the test is. But there isn't anywhere at the moment that does that.
I think if you've got an independent commissioning agent, you increase your chance of covering those issues. But when the contractor is doing his own commissioning, the vested interest is he may not be necessarily be with the end user who's paying for the facility. And this is, everyone's got a vested interest.
They're the contractor in those types of, and that's very common, isn't it? But the contractor then makes sure that all the individual manufacturers of the equipment, the power, the cooling, the switchgear, all that stuff, attend the system integrated system test, and they attend, and they have to participate, and they have to cooperate, but they don't have to step forward and help and make it more complicated. They just sit back and say, okay, well, when you want my equipment to work, tell me, I'll turn it on.
And if it doesn't work, then you're there on site to make it work.
Yeah, exactly.
So in terms of just maybe two more points, are you going to start producing a sort of best practice guide on a dare I say, a sort of general level, and then maybe gradually drill down into each of you've mentioned various disciplines to put more sophisticated advice together even. And the second point is we read or hear almost daily of a skills shortage in the industry. If the situation is bad, or however you characterize it at the moment, not perfect, do you think it's in danger of getting worse when you're going to lose, at the moment there are presumably folks nearing retirement who do have quite a lot of this knowledge you guys are sharing as well, so they do understand, but somebody who's just coming into the industry perhaps doesn't understand all this, so I say there's a danger of it getting worse before it gets better. Paul, maybe.
If we, yeah.
Oh, yeah, okay. Whichever. Paul, yeah, let's go, Paul.
Well, I'll step in on that. I think the involvement with your magazine and this interview and the articles we've recently written has given us a momentum through this last lockdown, and as we come through that, we'll be able to come together to meet up and to start it properly, shall we say. It's a lot easier around the table than across the video calls. So I'm looking to hopefully bring everybody in, and if we can find somewhere with Steve to meet up, then that'll be a good starting point. And we can, and in terms of the knowledge, this is part of what the group's set up to do. We've got to have if we had a 5-year roadmap, then I'd be disappointed if Ian's still I'll choose the words carefully.
What were you going to say next?
We should be well retired by then, by the time we get to the end of the 5 years. We'll have to tell him to stop if anyone is brave enough to do that. But we've got to be well on our way to get this information into the next phase of commissioning, of testing, of engineers coming into the industry. Because if you understand how it's been tested, you can understand how to maintain it and use it.
As well, that's the other problem with operations in data centers, is that far too many clients don't let the operators actually operate it. If it's working, you leave it alone. Don't whatever you do, don't turn it off and test it. No, so they end up saving up the failures. When the failures come, the poor sods that are working there, the poor individuals that are working there, haven't ever been faced with this emergency in the middle of the night on a late night shift of the alarms going off and wondering what button to push, and lo and behold, they push the wrong button, and you end up with a failure of some part of the load or other. So I think part of the special interest groups sort of knowledge bank will be, it's not just a question of playing with it when you're commissioning it, because that's the last time most people ever get to play with it. And it's a question of how do you then take that information and make it available to the people that are on 3 shifts a day trying to keep the thing running. About the skill shortage, you said, and I don't know whether there is a skill shortage. There is in some areas, clearly, because not enough of our younger people want to go into engineering. That's one of the problems we've got. But I'm always reminded of, someone once told me, and I can't remember who it was. I think it was a guy called Roy Shenton told me this. He's now sadly dead, but one of my bosses before I was in data centers, really good guy, electrical engineer. He said, he defined experience, and he said, lad, experience is a big, thick book of your own mistakes, and that's why I can't teach it to you. And so all you can do is you can pass on little stories, you can pass on experiences. Hopefully then people can form their own experiences by avoiding problems, or at least understanding other people's problems. And those things aren't generally taught. If you teach someone about UPSs, you don't tell them about how many times it happened that a service engineer was on site and put the UPS to bypass to service it, but didn't check that the bypass breaker was live, and actually transferred the live load to the bypass against a dead supply and lost the load. Happens all the time. Well, it used to anyway. I think it still does, actually. Like one I investigated last year happened exactly the same. The point is that when the manufacturer of the UPS is telling you how it works and how to clean it and service it and take the data from it and analyze the data, they don't tell you the practical things like if you ever put it into bypass, make sure the supply's live, because it sounds so daft, yeah, that you think, oh, surely that couldn't happen. I mean, little things like the service engineer goes into the generator room, turns off the battery charger to service the starter motor, the starter battery for the genset, does it all and forgets to put the charger back on. 6 months later, battery's flat. Or he forgets to turn the generator from manual, which has prevented it starting, into auto, which means it'll start automatically. And then someone a long time before had forgotten to put two little wires to the auto manual switch and put an alarm in the network operation center. That's all it needs. It needs a 10 bob switch and a few pounds worth of 1 mil wire and a lamp. It says, beware, the generator's in manual. And then every couple of months you hear of someone having a generator failure, and you look at it and you're asked to give a comment on it, and you say, well, you can change it from a generator failure to a design failure in the original data center because no one thought of putting an alarm on that system. All those things, and testing is all about that. You know, when you turn something off to test it, you need to test it correctly, and then you need a proper experienced person to actually say how to turn it off and how to turn it back on again. Covering.
I think there's an important comment that's come out of what you just said, Ian, and that's when people are being trained, the cost of actually training the people and the drive for money efficiencies doesn't necessarily mean that people are going to get that knowledge. They're not going to be put on the training course. They're not going to invest in the teams. They're going to expect this to be understood per se. If the DCA produce this document, then it's not free because we've all put our time and effort into it, but it's allowing a resource to be available which may not be invested in. So we are giving this there is a service, a gift to the industry, which is what the trade body is going to be able to do. I mean, we obviously want companies to come involved and to sponsor and to be members. Yeah. And this is I
think the point though, Paul, is that it can be free, but the point is it's wrong to think that free means someone else is giving it away, because in my view, there's too much pressure being put historically on the cost of testing, too much pressure put on the cost of equipment for testing, so you end up with fairly simple tests. See, I think we've discussed this before. My view is that all load banks should have an element of capacitance or inductive section to it, not just resistance, because I think the loads are not resistive. So what good is it testing it just with resistance? And it's cheapest. So in terms of payback, I think if the industry put in the right amount of information and made it accessible enough, free, then people would realize the importance of using fairly advanced testing equipment, which would actually cost a bit more, but it would then avoid a lot of problems. And to your point about training, it's not just a question of having them on site when the commissioning is going on, which is a great idea, but the operators. But then, of course, 5 years later, half of them have left and gone somewhere else. Yeah. And those that come in may have come from another data center and may bring experience with them, but they're more likely to come from somewhere else and not bring the experience of that criticality, 24 hours on, never allowed off, not even allowed to shut down 2 o'clock Christmas morning because someone thinks it's an important time of the operation for the data center. But in that respect, that the data centers are very special, is that we've become very used to society not to allow them to ever be switched off. We complain. We say, well, God, what's wrong with my, oh, look at this, won't work. Why not? It's because someone, think about anything else. Imagine how long your car would last if you drove it down the road and you only ever stopped it and then kept the engine running and just put fuel in it and drove it off again. Your average saloon will last a year. Yeah, it will last you 15 years if you use it properly because you keep turning it off and parking it. But it's an interesting view.
We've actually just done that. We took a lease on a little small. It's not quite the transit van, one down from that size, and it's been driven to one factory to another, and in 18 months it's got 1,500 miles on the clock, and the engine management light came on, and we took it to the garage, and lo and behold, it was because the air filter was blocked and we hadn't driven it on the motorway enough. So if we could have had a low bank on the diesel van, then it would have solved the problem. But their suggestion was to run it around the M60 for a couple of hours. So, yeah.
Okay. No, that's brilliant. So, gents, I really appreciate your time. We covered a lot of ground and some great insight. And hopefully, I think the plan is to follow up maybe in a few months' time to see where you've got to, what's going on. But for now, thanks very much indeed for your time. Thanks, Paul. Thanks, Ian.
Thank you.
Thank you.